Hi everyone, this is Lina. I'm going to present the database components of our project. So we've implemented our database using SQLite, a lightweight and file-based system. The database is designed to handle data archiving and other functions and also support the operational needs of our system. It contains 11 tables. So each table tailored to store specific information, ranging from the customer, store, orders to the download history, order transfers, and order history. Let's dive into some of these tables. For example, the customer table, it records the account ID, rating, credits information, and the John table, it record details about each John, like the weight capacity, remaining chips. And we've made several modifications to our database since its initial design. For example, as part of enhancement to handle the dynamic lightning storm in our simulation, we've incorporated location data into several tables. The store table, John table, and the order table. And you can see the X coordinate, Y coordinate columns here. In addition to that, the John table now also has the speed, health, delivery list columns. So all these enhancements allow us to simulate the impact of lightning storm on John performance and its health. So one of our database strengths is its ability to check the intricate details. Take the order transfers table, for example. It keeps a record of each transfer. It records the order ID, the store name, and the John ID, the order transfer from, and the John ID, the order transfer to. So these enhancements to our database are very important in making our drone delivery simulation more complex and realistic, accounting for environmental factors while focusing on the robustness of our system.
Hello everyone, I'm Liang. I'm introduced the fourth of our three modifications to the draw delivery system, improving authorization and authentications. Our existing system is quite open. Everyone has the same level of access, which isn't great for security and data integrity. First of all, we're introducing a new feature for user account creation. Users will be able to create accounts with a unique username and password. And this user information will be stored in a new database system, as my teammate previously introduced. Password will be hashed to promote the security. You can see this is the user table of our database. We're also adding a validation process to ensure that all account operations are valid, along with the user's role and their login status. You can see this is our command manager class, where we have customized commands for each role. Basically, the customer role has limited permission. They can only view the store catalog, initiate order, add item to their orders, check out, and cancel their orders. Employee has more service-related functions. They can also create store catalog, manage draw, and orders. Manager level role has full access to all system functions. Now let me show how these features work in practice. I'll run my Docker, building the image. Okay. Firstly, I'll try to log into my account. Use the wrong password. No, login failed because the password is wrong. Okay, I'll try the correct password. Login successfully. Now let's display users. This is currently the user in the database. Let's make a new user with a manager role. Alex Johnson. Okay, change complete. Let's make a regular employee, Michael Smith. Okay, change complete. Let's try display users again. Now, Alex Johnson, who is a manager, Michael Smith is employee. They are all now in the database now. So their login status is false. My login status is true. Let's make a palette. Okay. And let's make a customer. Okay. So let's display palettes to see. Okay, David Wang's here. Let's display customer. Okay, Amy Brown, the new customer is here. Now I'll log out. I log out from my account and log in as Amy Brown, our new customer. Okay, Amy Brown's logged in. Let her try display item for fresh market. Okay, display completed. You can see it now. Then let her try display customers. Error. User doesn't have permission to display customer because the customer role doesn't have the permission to display all other customers. Let's log out and log in as our employee. Oh, sorry. Michael Smith. Michael Smith now is logged in. Let's try display customer again. Yes, it works because employee has this permission to run. Let's try display efficiency. No, employee doesn't have permission to run display efficiency. Let's log out again. And finally, let's log in as our manager, Alex Johnson, we just created. Now try display, oh, sorry. Display efficiency. Let's not just tap it. Display efficiency. It works. So this is our new feature for role-based access control. Then my teammate will present the next item. Thanks. I'll stop it. All right.
Now, let me show you some of the commands we've implemented. So as you can see in the screen, I've built the Docker image and we started to run our application in the Docker container. So let's first log in at the user manager. And let's see what we have for stores in our current database. So now we only have one store here. So let's make a new store. And now we already have two stores here in our database. And then create an item to sell in the new store. And then we can create a few customers for the new store. And then we also can create the pilots. So let's see how many pilots we have already. So we have 5 pilots. And now let's create the drones here. So let's create 2 drones for the new store. So we have 2 new drones for the shop, our new store here. Next, let's assign pilots to the stores, to the drones. And we can use the display drones to see, okay, it works. You can see the flow by these 2 pilots. And now let's create some orders. Okay, so we've created 2 orders here. Let's see by using display orders. Yes, it is added. And then we can add some item to these 2 orders. I've added some debugging log here so you can see the exchange completed. So let's see our drones. So you can see the change for the remaining cap for each drones and the number of orders. So let's do a transfer order. It says it doesn't have the enough cap capacity. So let's check. And then maybe we can move to the order. So it's current drone, and then maybe we can move to 2. All right. Sorry. But it should have the capacity.
I'll be presenting our latest feature integration into the Gothard Express project, the concept of lightning storms. Let's start with the storm class. This class is crucial for simulating lightning storms in our delivery system. It uses various attributes to represent a storm. For instance, top left and bottom right are point objects defining the geographic boundaries of the storm on our system map. Other attributes like likelihood, frequency, duration, and damage level allows us to control how often storms occur, how long they last, and how severe they are. Additionally, we implemented direction attributes to simulate the movement of the storm across the map, adding a dynamic aspect to our simulation. To represent location in our system, we use the point class. Since we don't have a real map integrated yet, point helps us define locations using x and y coordinates. This class is fundamental in setting up the geographical aspects of our storm simulation. Now, let's talk about the Move Drone class. This class is responsible for the movement of drones within our system. It interacts with OrderDAO, DroneDAO, and StoreDAO to manage orders, drones, and stores respectively. The key functionality here is how this class interacts with our storm simulation. As the drone moves, the Move Drone class continuously checks for any active storms in the vicinity. If a storm is detected and the risk of the drone being struck by lightning is high, the system takes immediate action. This could include rerouting the drone to avoid the storm, or if a strike occurs, handling the aftermath like damage assessment and reinitiating the delivery process with a replacement drone. Okay, now we will proceed to the practical demonstration of our system running in a Docker environment. We will showcase 3 distinct scenarios to illustrate the system's response under varying conditions. Before we begin, I want to mention that to simulate these scenarios efficiently, since our original implementation is to use random numbers to determine the likelihood of certain events, such as drone strikes, to save time and ensure clarity in our demonstration, I have pre-initiated some data that will allow us to witness these 3 different cases more efficiently. Let me start the Docker now. Okay, first let's observe a scenario where everything goes as planned. We have a drone that successfully delivers an order. I am now starting the system. Let me log in. Display some data. So I have some stores, pilots, drones, and others in my database. And you can also see the drone's position is 0 and 0, and the other's position is 6 and 9. And I'm now going to make a storm. And you can also adjust the likelihood and damage level of the storm. Let's display a storm. So here we created a storm, and now we can trigger the movement. Let me display the drones again. And you can see now the drone's position is 0 and 2, because the speed of the drone is 2, so here we updated the position. And let us continue trigger the movement. And maybe display a storm. And you can see the storm also moved. And display drones again. And you can see the current position is 4 and 6. And the health level for the drone now is 7. So we can continue trigger the movement. Okay, now the order is finished. And let me display the stores. And you can see the revenue increased, which means the order is delivered. So this is our first scenario. Next, we will see what happens when a drone's health drops below a certain threshold. In this case, less than 3 points. The same as before, we have some stores and orders in database, but this time, I will increase the likelihood and also the damage level. Also, let me log in. Display stores. And we have a drone. And the order. I increased the likelihood of the storm to 90 and also the damage level to 8. So it will get higher chance to damage by the lightning. now we can trigger the movement. Okay, let's display the drones. Drone moved. We can trigger again. Okay, now you can see it. We have drone. It still go back to the store because we have the health level of the drone below 3, so it need to go back to store for the maintenance and also the item replacement. And now we can display drone. Okay, so it go back to the rendezvous, which is the store's position. And now we have to go over again to trigger movement to re-deliver the order again. So this is our second scenario that drone is to go back to the store. Lastly, we will demonstrate what happens when a drone's health becomes negative, indicating it's been ruined. We have drones and stores as before. And this time we will take the likelihood to 80 and the damage level to 6. And now we can trigger movement. Looks good. Looks good. So as you can see, after 7 movements, drone is damaged because the health level of the drone is negative now, and now you have to transfer the order to other drone. So if we display the drone again, and you can see there is no drone under the store because the drone is ruined. So this is our last scenario that when drone's health falls below 0, our system recognizes the drone as inoperable.
Hi, I'm Yi. I will introduce the archivability part. In order to implement the non-functional modification archivability, we utilize the database segregation. We created 2 databases and connect both of them to our Java project. The primary database, which is named as the grocery database, is designed for swift CRUD operation. CRUD operations stand for create, read, update, and delete operations. The primary database will cater to both ongoing and recent drone delivery service activities. This includes real-time data operations such as order creation, drone tracking, and customer interaction. The secondary database is optimized for long-term storage, ensuring data longevity without impacting the performance of our primary database operation. Order records, once they reach their archivable standards, will be transferred to this database. The data transfer approach aimed to achieve a balance between operational efficiency and data availability, optimizing for both performance and cost. We will archive 3 kinds of data. The first kind is customer profiles that have not shown engagement for 1 year. The second kind is data related to stores, drones, and the pilot that have not seen activities for the past 6 months. And the third kind is orders and item lines after 3 months of creation or last update. Now I will show how archive customer archive zones, archive zones, and archive pilot. These four methods work. Firstly, let's take a look at what data we have in our primary database, the grocery database. Now we can see the customer table. We have several customer profiles. Some are still active recently, and some have shown no engagement for 1 year. And this data are what we need to archive. About the storm table, we can also find some data need to be archived. For example, Samsung has seen no activities for the past 6 months, and the pilot table and the join table are the same. They also have some data need to be archived. Now we can take a look at the archive database. Let's take a look at what this table look like. As you can see, for the customer archive table is empty now. And also for the store archive table, it's empty. And also for the pilot, the drawing archive, they are all empty.
Now I'm going to show how to run archive function in Docker environment. Run Docker, archive. Database is archived successfully. That's it. Thank you.
After running the archive command, let's take a look at what data is in the primary database now. Now we are in the grocery database, which is a primary database. We can see that our customer, storm, pilot, and dorm table only have data which are recently active. And then let's take a look at the archive database. What data it has now? We're in the archive database. We can see that the 4 tables here now have the archived data, which have not been active for 1 year or 6 months. This data are what we need to archive.
Hi, I'd like to demonstrate our proof project for archive order. Our is group 36. We have generated 2 databases. One is a primary database called grocery database, and the other is the archive database. To demonstrate the orders, we have generated 4 data. Purchase A and purchase B is the older data, which older than 3 months. Is our target want to transfer into the archive database. The more detailed information for the order can be found in the item 9, such as the purchase A, the detailed item name, and the quantity, and the purchase B. Before we execute the command in the archive database, order archive, there's nothing inside. The same thing for the item 9. So we run our comments in the terminal. Once I run the comments, we can go back to chat. The item 9 archive, the 2 items has been successfully transferred into it. Same thing is the order archive, the purchase A and purchase B. And the original data in the grocery database, the orders, these 2 data has successfully delivered from our original database. The same thing is for the item now, which suggests that the older data has successfully transferred into the archive database and stored the original data in the original database, which freed the space